Hello, and I welcome you again to this part of tutorial which will be about pointers in C. Now, pointers are a very important topic in C because you can do a lot of things with pointers. They are needed at many places. We have already seen pass by reference or pass by address. So let's try to learn more about pointers and how we can use pointers in our programs. First thing to note about is pointers are derived types. As I have already said when we were discussing arrays, that arrays are derived types. Similarly, pointers are derived types. You can have pointer to character, you can have pointer to integer, you can have pointer to float, pointer to any basic type. In fact, you can have pointer to arrays, pointer to pointers, pointer to function, pointer to structure. And what does a pointer store? It stores the address of some other variable. This variable can be any type. It can be a pointer also. It can be an address of an array. It can be address of a structure. Later on we will see that pointers are also used to allocate dynamic memory. When we say dynamic memory, that means at runtime you will allocate memory on heap. We'll see what heap is, what is stack. So the point about heap is that we have seen that when we have something on stack, we need to pass it by address. If we do not pass it by address, then that value is lost if it is on stack and stack frame unwinds. However, if it is on heap, then it is persistent. There is no stack frame unwinding. We'll see the C memory model in next slides, that how stack and heap are arranged. As I already said, pointers are very powerful and you can do a lot using them. Almost any data structure you imagine, be it a stack or queue, linked list, doubly linked list, graph, binary trees, they're all implemented using pointers. The downside of a pointer is that its syntax is complex. It is confusing rather, because it can be on stack or it can be on heap. However, when you will practice, it will become more and more clear over a period of time. So nothing to worry about that. When you have programming language, certain pieces can be complex, certain will be easy, and pointers is one of the slightly complex elements. But I'm not trying to make you afraid, but I'm rather making you realize that you should be careful while using pointers. One of the problems is that when you have multiple levels of indirection, then it becomes difficult to understand. You need to draw diagrams of memory locations and then you need to find out what is going on. As I said, you can allocate pointers on heap, that is memory on heap. However, when you allocate memory on heap, you need to free it. If you do not free it, then memory leak will act like as cancer to your program and your system. Most of the programs which we have seen till now are like 10 seconds. They run for 10 seconds, maybe 15, maybe 20. However, there are programs which run for years, like a web server or a database server. Even operating systems. Servers are not rebooted. There are systems which are booted once in their lifetime and when their hardware fails, then they are replaced. So when you have such long running software and you are having memory leak, in memory leak what happens is that your program will continuously consume more and more memory. So when you have memory leak, it will eventually consume all the memory in your system and your system will come to halt. Your system will not be able to do anything. It will freeze. It will hang. Now, to manage pointers on heap, there are 4 functions: malloc, calloc, realloc, and free. We'll see when we will deal with dynamic memory allocations. When you do dynamic memory allocation, you need to manage wild and dangling pointers. Let us see the memory model diagram of C. So, this is how your memory model looks like. At the top, you have got stack, and below it you have heap, and in between there is free memory. This is how operating system will allocate memory to your program. Now, stack will grow downwards and heap will grow upwards, because that is the best way to optimize memory allocation. Below heap, you have got data segment where other parts of the programs are there, static variables and global variables and other things. And below it, you have got code segment where the assembly instructions of the program will stay. Now, our pointers can be on stack or can be on heap. When they are on heap, you need to take special care while freeing the program. I will again repeat this fact that if you want to become a good programmer, you must understand pointers. Its syntax is a bit difficult in the beginning, but there is no denying the fact that if you do not understand the syntax, then you will not become a good programmer. I will help you to explain and understand the basic syntax of pointers, and when a pointer is on stack, when a pointer is on heap. The very easy way to identify this is by looking at the functions. When you allocate using malloc or calloc or realloc, then the pointer is on heap. Otherwise, the pointer is on stack. You do not need to worry about data segment or code segment at this moment. What you need to worry about right now is stack pointers and the basic syntax. If you understand the basic syntax, which we will see when we will do hands-on, then there is no problem and you will be able to manage pointers and use them to benefit of your program. So I'll see you in the hands-on section, which is going to be a crucial section in our discussion of programming with C. Till then, happy coding.